We're gonna leave the introduction a little short today. So, as I'm sure you probably noticed by streaming on Sunday, I still haven't the fact that I haven't posted anything yet. I hope my mic audio is doing better than that, but we'll see how it goes. So, hello and welcome to Bug Free Productions. We're gonna flip over to the screen a bit earlier. So, what you should see on this is JSON continues. Now we're going to continue the JSON object saving system. Actually, just kind of a recap of the entire system, where it ended up, because I did find those last few fixes. They'll be ready to go, and everybody can use those in their, or use that information in their development process. So let's go ahead and get going with that. So, as always, you can check out live on Twitch if you're watching this after the fact. You can watch Twitch live demos at Jib at BFP on Twitch TV, or you can always watch back if you get lost on this at some point and watch it on the YouTube channel at Bug Free Production. We'll go ahead and get started on this particular one. I'm just going to make sure to pause this audio so that we don't play through too much, and we'll get going with the first script. So first of all, we kind of did object placement. So if you remember, we actually started with the gateway, which is a simple thing with JSON, which uh, was bug free from the start because I kind of just edited a different file gateway. But basically, I'm making a gateway to go outside of my um, Unity project into the local folder path, which I use application.persistentDataPath to navigate because Unity provides this, which is a consistent place to at least semi-securely store data. So like we won't want to load a bunch of stuff from here necessarily for like multiplayer settings, but for local settings and local save files, this is a perfectly good place to save things. Um, and then this just has a read JSON file and a write JSON file. Um, These are specific to this custom gateway stream writer, so this just writes out the object we wanted to write, which writes it to persistent data path plus a path, which is usually my file extension, so it's the um, document.txt file, so to speak, but in this case it's document.json. And if you ever need to look up your paths, you can just Google the default Unity path. They do provide that in the documentation for Windows, for Unity, for the path for Windows. And StreamWriter.write is just a basic thing that you'll use quite a bit if you start working with local saving and saving of text files. And StreamWriter.close is just closing the StreamWriter that we do indeed open. So just making sure we uh, dump all those resources when we're done using them. So that being said, this worked. So we're running through the logic, and then I'm going to visit the fixes that I implemented to make it fully functional, which was just a typo. Spoiler. But from there, we had to go to, I think, Placeable Object Writer. So we developed Placeable Object Writer, was used to test our write object placement data, which was used to write to our object placement read write. So this is a separate thing that we'll go to, which this was actually developed before the writer, but any case, object placement write is using a file path, which is where we set our objects to be saved to. We could make this serialized and changeable for editors to make multiple of these, but being that this is the one system for saving JSON objects, it might be better for us to keep this from the user. Um, you'll notice private static object placement read write instance. Right, because this is a singleton, and I wasn't necessarily thinking about that when I created this. Um, so actually, this could even be private. It won't affect the functionality of our code to change it, except for the fact that less things can read slash write to this information. And the reason I had it protected, usually if I inherit a field, I want to keep it protected so that further subclasses can inherit from it. But if you have a setup like this where I use instance or make an instance, so I know that it is indeed a singleton class, the code I use to create a singleton is not necessarily able to be inherited. So instead of protected methods, I might as well use private to make it even more secure. Um, is my logic through that. Um, and this is just singleton code. So if you followed along, um, I went through this construction. If you haven't, maybe go back and watch those ones if you're interested in uh, learning what my process for creating a JSON read-write system was after this video. And then we have project placement read-write. So that's pretty good. This is just a constructor because I don't really need to set any values in the instructor. It is pretty much just empty. Um, so yeah, I pretty much just did this because I wanted to make sure I had an empty constructor that did nothing and then also had access to this type of thing here. So that pretty much sums up that one. We'll go backwards one space, maybe two space. There we go. Just wanted to go back a file, and we have write placement data and write test. So this write test pretty much isn't used anymore. Oh, wait, no, write test is used. So placeable object writer, this has a write test. The reason I called it test is because this is what I'm using, and it's using input action callback context just so that I can use my input system to connect to it and um, switch over easily and test it by button click rather than to come here. There we go. Rather than the alternative, which would be to um, either use the old input system side by side and write it on key press or whatever. It's just for my ease of testing. And it just calls the right placement data that we'll eventually use later, um, which if we're eventually using it later, this should probably be public. Um, but we'll see how that goes later because I'm not certain if I want every object to just be able to call to this either. That would kind of suck. So imagine if like your character could just call out and save, or every student could call out and save. Might have to do a little bit of testing on that, um, determining what level that needs to be going into. So we're gonna go ahead and uh, we're gonna go ahead and do some stuff on that later, possibly. The next step is abstract factory SCO. So object writer is mono behavior because this guy is essentially just for testing for the most part. We're going to go ahead and go to the abstract factory that we used. And the abstract factory that I made is the same abstract factory that I made for or no, this abstract factory abstracts the factory uh, calling process. So this factory is a factory that basically calls other factories, passing in a key of sorts. So it's a scriptable object, uh, and this has a list of factories, which is generic factory SCO. Takes in all those SCOs, and basically when I create an item, I can do it with a transform and a string. And when I do that, I use the string, pass it into um, this for loop that searches through each factory, and if the factory ID equals the other factory ID, um, then it builds a thing. Now that I'm looking at this, this could be simplified. So if we just send the ID, if we're already, okay. So while this isn't the simplest one, we could just send the string to each one of those factories, and then those factories would have to run, um, and just create something if it matches. We do have, um, this technically would be faster because as soon as the IDs match, it would stop running. You know, if that would be a long, complicated check, it really doesn't make much difference either way you would do it too much, I don't think, because they're such short executions. Um, and then we have create item. We have create item string search string ID, and then we have a factory ID, which a factory ID is set equal to null, so that um, just for a null check, I think it was, and then the generic factory in factory SCOs and factory ID um, generic factory dot ID item ID. If string equals that, then create item a placement. So this one being a string, or being that we create an item, transform, and a string ID, we could theoretically create anything with the string through this. So we could use this to make our, I also did this so I didn't have to change my regular factory to include string method overload for transform and a string. Which isn't a big deal, but it would have been an extra step. So essentially we can do this and continue to use our firing factory the same way if we were to set up an abstract ammunition factory, which is kind of interesting. Then we have an object placement list, gather factory item position info. Object placement list. See, this was the thing I was kind of debating about changing this from an object placement list to just a list of object placements and then sending that out to get changed later. Honestly, it's working right now, and I don't think it's worth changing right currently. Um, but if I was having trouble with legibility of the different methods, that might be something I come back and change later. Uh, for each generic factory, and then we do this, we get the position info for each placement op in NL. So for each object placement in new list. So basically we assign the list in there, and then we add each one of those in there and return the list objects place return or ret list dot object placements is equal to total objects dot to array. So the object placements inside the object placements list class that is serializable is equal to the return that we got in retlist, where we added everything from this for each loop into, and then we return that list, which would go back to which is called by, rather, um, the placeable object writer. Once this is run, this is stored in OPL, object placement list, which is then passed to object placement read write dot instance object write object placements OPL uh, as a parameter. So if we follow that, basically that's just writing that we viewed in our, what was this called? Object placements read write, and custom gateway.json.instance write JSON file placement path. Writing JSON file, yep, and passing our placement path and our JSON string. Placement path being, again, the space where we want to store it. Starting with a slash to designate new file object placements.json. There was one more thing that we had to change. So since we changed the way we create items, we had to change the way we created item in factory a little bit. So we created this is our regular transform one, which is the reason we didn't create another method with the string. Instead, we just use that. And then we create item. So create item, object placement is the one we use when we write or when we read back in a file. And pool check ref afact if afact not equal null. So if we have a factory that is not equal null, poolable. This is probably supposed to be a fact item. No. Let's look at it. What's a fact? Okay. A fact is a local variable for this. It's local to this method, kind of. So poolable a fact equal null. So we're basically saying a poolable object is null. Pool check ref a fact. So if we check the pool for objects that we can use, it'll be set equal to that. So if that is not any longer null, then we know we have one to use. So we go to the factory item. So we declare factory item .fi and look for on that item we got back a poolable. We look for the factory item, and if that's not equal null, then we use the factory item. Which is just a null check in case I forgot to put one on the other, because I might not always use them together. And we don't want user to ever see errors, so we'll do stuff like this, or we might debug to system if something fails. So I could do an else statement here and do debug, but which I probably would do if I was working in a bigger team. Game object ngo or instantiate factory item. All of this is just the standard an instantiation, and then we throw it to use factory item, which is cool. And then we have that, which kind of ends in the region, gather items. So again, this is from the factory. This factory returns just a list of object placement. So goes to every item and says, what is your object placement? And then the placement return, and then that factory item returns a placement for us to store in the list. So that would be, for example, object placement, which we kind of went over. This is actually where the error was. So two types of things I did to make it a little easier to make sure my code was correct. Um, this is one thing that scared me, object rotation. I was afraid that using Euler angles here every time might become inconsistent on some types of rotation. So to neutralize that worry, I went with a vector3 object rot equal transform Euler dot angles, and then from object rot did that so that it's only um, deciding on the x, y, and z once, because I was afraid it might be redeciding those, because quaternions actually have four four values to determine its rotation. So I didn't want to have like x, y, and z that should be from the same idea of value, but don't come out that way. And then this was a less of a worry, but when I was troubleshooting, I was just like, I really want to know if that was my problem, and it was not. These were not any of the problem. It was I accidentally had TPZ instead of TRZ. So it was looking at the position that was saved instead of the rotation that was saved, which was causing me weird rotations and then weird positions because the rotation wasn't correct. So just really weird on that part, which shows you how hard it is to troubleshoot some of this. I actually only figured it out because um, my position on the Z wasn't saving. So I'm like, okay, it's got to be on one of the Z recording methods. It's the only place it can be. So that's how we got to there. And then we have object that's returned and that. So for the most part, that actually fully sums up what was going on with this particular thing, right? Um, as you can see, I can play and it spawns, and based on the logic, this is where it was last time. So if I move it over, click on this, hit my save key, and play, and it should show up where it was, which is, yep, about there. So save system fully works on position, save, read, write. So that's pretty cool. I knew this would probably only take about a half hour to an hour. So what we're actually gonna look at is trying to work on some more um, camera. So, but the reason I didn't title the video that is because I didn't know if I was gonna frick it up and take forever to actually troubleshoot this either, which could have happened. Anyone that's been in any kind of development setup, you know that sometimes you make not even necessarily a mistake, but you just don't fully know what the thing you're trying to fix is. So you have to pin it down. And for some problems, it's actually kind of funny. I was told I fixed something very fast one time. I'm like, it took me 3 weeks to fix this issue. How was that fast? And it just is. It's one of those weird things in software development where it's like some things can take 3 weeks and some things take you 10 minutes, um, especially when it comes to bug fixes. Um, so, to all those new to this project, this actually isn't a flat plane capsule with cubes and circles. This is a project for bike races. But you can't see the project name up in the corner. So if you go back, you can watch all the video stuff on that and see the other things that were going on. I'm gonna actually load a new scene now and do a little more development on a different scene, the bike scene. And what am I gonna do now? Okay, so why would you fix the camera? What's wrong with the camera that needs to be fixed? To both I say, nothing is wrong with the camera. The thing is, if I were to go and add more states to this right now, that we're still moving states, right? So let's say I want to move forward, and I'm not gonna, even if I was to incorporate a reverse, right? Um, how do I, since this is a 360 for me, 360 degrees rotation management for me, not for you guys, but for me, how do I uh, grapple with that idea without having to calculate a whole crap ton of angles? Well, actually, I had this idea today that I would simply modify, or not modify, I would simply use the velocity. Um, to those of you that might not quite um, see what I'm talking about just yet, if you think about the velocity and it's always the direction that you're heading, right? So your camera would still always be facing forward, even if your, say, object body was rotating, right? So if we use the velocity instead of the forward transform, we can actually create a camera that follows the um, forward momentum of the vehicle rather than following the transform position of the body and its rotation. So it separates the camera from the um, player. No, it separates the camera from the controller a little more, um, while still giving us the opportunity to select how far away from player we want to be and stuff, and still use some of that same logic that we made in our current camera controller, but also allow us a little more usability in terms of animations and other types of things. That is the hope. Um, we will find out if I'm good enough to program this one. So, but basically, this is going to come down to I need to go into assets, scripts, and I'm going to need some camera stuff. I'll probably pretty much just close all my JSON gateway stuff. Oop, what did I not, what did I not save about factory item before I close? I deleted the debug.log statement. Yep. Since everything was working and I don't think I changed anything that would break it, I'm just gonna go Control Shift S to save all files and then just blop, 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 cut through all these guys, cut through them all, cut through them all. I'm gonna leave bug free tool up just because sometimes you're working on something and you just like, oh, I need this like almost every day, so I should put some tools in here. And that's kind of where I add them. Um, I definitely suggest having your own static tool list. Um, static tool list being just like collection of static methods that you would need a lot for different things because it doesn't necessarily always need to be in reference to a very specific object that you're working on. sometimes it's just like some math processes that aren't included in certain libraries, like angle calculation. I'm not sure if there's or what the library for C sharp is that does all of that. So I just included it in the static class, coded it quickly, um, which was a lot easier. With that, I'm gonna take a drink of water, and then we'll continue here. So, um, camera state. Let's familiarize with camera state again. Camera state is new camera targets. Look to vector 3, look to. So where's look to? Nope, look to is sent out. Racer camera context. Okay, so that's promising. We have a context here. And I'll let my context point back or have a value that we can give them for rigid body, which is good, which is kind of what we're going to be looking to do here. Look to and look from. So that's just calculating that way. So this will all be very similar, but it'll be in relation to the uh, velocity of our vehicle, which will cause the camera to look down at it, which is a separate issue we'll have to test for and see how well that works. Uh, because obviously you still want to be looking kind of at your vehicle. You don't want to be looking away from your vehicle, so there might be some unit adjustment that we have to go through, some units that have to be adjusted. For the most part, it should work okay though. But yeah, let's go ahead and do that then. Let's go to where camera context is defined. Let's just, actually, I'm not going to do it that way. Because it's hard to, it's just that I drag it around and it makes a really just crappy video experience. So we'll open it that way, which is still flickery, but there's only so much we can do. Racer camera movement. Um, so that's camera state. What does it have? It just has state bars as STOs. Okay. Camera objects has an object. Okay. Does it not have a reference to a move state? It does not. Well, that kind of sucks, huh? Because our things are going to need reference to that type of thing, right? So that kind of kills it, doesn't it? So how would we get, let's just go back to Unity then and plan our attack here. Opening byte container, the whole body. So this is what should be on your robot body, I believe. And I'll probably just have to look for my camera, but my camera won't be on here because my move context actually has reference to that camera. Which is hmm cam Racer camera, is it not shown? Whoop, Control F, not Control V. Racer camera, context right here. It's protected, it's at the end. So I'll go back to Unity. It's not really visible there, is it? Camera reference. So why is this? Oh, it's not serialized field, but it's referenced, isn't it? RCC. Get component. Racer camera context. Is it using get component? I don't remember doing that, but yeah, there it is. Okay. Well, actually, that makes it really easy if it reaches out to the camera and manipulates the camera outside of this. That makes it really easy because what makes it super easy is then I can just do the same thing for eraser camera context and just use get component to get it. Which should make my life a lot easier than having to assign it, and also then user doesn't have to do that either. So that works for me. Um, so let's go ahead and do that on eraser camera context. That's why I say there's a lot of just refresh sometimes. Class state variables. SCO references and camera objects. So I probably want another cam from. Okay, that's for other stuff. Not worried about that. Let's go ahead and do a new region. Now why would I do a new region? I just prefer it because I might have additional context in here. Um, and if there's other information I need to pull from move context that can't stay in there, it helps out with that. So then I have a pro TE protected. It's racer move context. Racer move context. RMC. Equal null for consistency because I do want to do a null check eventually. On enable this. So what else would it be? I'm probably going to put that in on enable for a second before I move it out, and it's going to be actually, you know what? Let's do it the right way and just, or not necessarily the right way, but the preferred way. So protected virtual void collect bars, and I can't remember to leave my words together. I don't know why it is, but when I write a paper, I leave my words connected together like they're supposed to be for method names. And when I write method names, I hit space for some reason. It really makes absolutely no sense. I don't understand it. But nonetheless, that's where we're at. I'm gonna do this in collect vars. Set default states. Collect. What would I do? I'm collecting, let's call it collecting a additional context. And if you see something spelled wrong, get used to it. I am nowhere near the worst spelling programmer, and you will read far, far worse. Just accept that as a rule. RMC. So this is going to be RMC. C is equal to get component race move context, which is perfectly fine. Cool. Is this where we want this? Set default states, current RS, idle, or CDS. I probably want, for no other reason than I already kind of earmarked this for collecting variables with the collect vars method. So I'll probably throw in like here and go like set defaults. No, VOID. Yeah, and I could make this like an accessor instead of a method, but nothing really benefited from that since I'm setting two properties anyway. That's fine. Then we'll call both set defaults and collect vars. Another reason I'm doing it that way is because I might set the defaults at some point and not collect variables. But that's a later concern as well. So this is set to collect the var. Okay, so now we step back a little bit and look at our thing a little bit more. So we have our context that has access to the move context, right? Which is good, because then we can do rmc.rb and get the rigid body and do that sort of thing. The next part comes down to identifying where the camera to and from was set, which we have. So we need to get the RB into there, which was the race move. The racer, was it camera manager or camera state? Camera state is where it's calculated. Camera manager velocity is not used. I think Bell is like some quaternion thing that I used. Transform position, RC dot time between fixed time at double time. That's movement. rock camera, loops between the two by a time. Okay, I did that. Which was covered in a earlier camera video. So if any of this doesn't make sense, feel free to look back and check those out. I'm not sure which ones they're under, but current val vector 3.0, not important. So camera manager is only in charge of moving and rotating the camera, and it uses it uses time position cam from RCC. So context. So the cam state throws the to from to the context, right? Cool. In that case, whew, a little water there. In that case, what do? In that case, I guess we can start with the point where we make that method call for the camera state, right? So calculate new camera targets. I was kind enough to label this region intelligently for myself. So what would this mean? This is where it's found. It's going by the forward, the anchor forward, to distance, negative forward. So basically we'll do something really similar with the vector 3. I'm actually going to calculate that out first up here because I'm not, this is getting to be a long line and I'm not a mathematician in any way. So I'm going to go ahead and create a new variable that's going to be a vector 3. Well, that has to be in 3D space. Needs 3 dimensions. A vector 3 that is we'll call it a what should we call it? I don't want to use movement direction. I am just gonna call it a forward direction. A forward dir is equal to, here's the other thing, ACC, or ARCC. How long do I want my reference to be? I do not want this reference to be super long either. I don't mind that I'm getting it from ARCC, but do I want to go ARCC dot RMC dot RB? Probably not for a usability standpoint. And most programmers are also going to be similarly lazy just because we don't want to read all that crap and have to remember all those calls. So probably go racer move, go back to racer move context, and we'll make a getter real quick. And you notice we have a lot of gets and sets at the end of this class. We probably have like, let's try and get a half count. I guess it doesn't tell me how many lines are selected, huh? Anyway, 224 to 265, so what, about 40, a little under 40, a little over 40, somewhere around the 40. And some of that's comment white space, but you know, It's a good amount of access. Um, and they're all just gets. None of them, none of them even have a set. Um, which isn't all that rare for my style, but so what do we want to do? We want to do access to our, I can't spell, so what I'm going to do is I'm going to type very good body. Eraser, public, very good body. I'm going to call this capital RB. Get return. Oh no, this is not right. Well, I should have known that when I saw camera context. I'm in the wrong script. There, that's much better. I'm like, why is RB a variable? I didn't make one yet. Um, but now we'll make that true. So I just want to make sure did I do anything stupid in that one. Let's just control Z and see if it does. Okay. So now that we see the star is gone and we can't undo anymore with control Z, let's move to the context. Okay, so up here and up here. So then I probably didn't. Yeah, I didn't change the region. And I don't want RB. I'm just going to do RMC. Race remove context, because why should I store it a second time? But I should serve it as a thing, because I want to know what rigid body my camera context is attached to as well. Um, even though technically it doesn't store the reference itself, it knows who should. Which you'll notice this is kind of deviating a little bit away from make everything. So it doesn't have to be um, so that it doesn't have to exist, but I need to make sure it works before I worry about refactoring some of it. Just kind of where this is. So erase from camera context. So now we're in the context. We go back to camera state because I have a terrible memory. A forward direction, vector3.0 is not what it's going to be. It's going to be arcc dot rb dot velocity. It's going to be, that's partly it. So rigid body velocity is in world space. units direction. So I need to calculate what a forward direction would be. Um, so what would a forward direction look like? The velocity is in terms of like if I normalize it, if I normalize it, it'll be a direction of 1, which will be good. So maybe I should do dot returns a normalized vector based on the current. Okay, dot normalized. Not to be confused with the method normalize, which would make my velocity a maximum of a normalized vector being 1 magnitude. So it means 1 unit movement total. So this is a representation of the direction in 1 unit total. Cam forward multiplied by from mult distance. So for the most part, I think this would actually be entirely just duplicatable. And I can just replace, because forward is also a term of direction in world space. And then this is the problem with it comes when there's a 0. So in order to solve for that, that's quite easy. Let's open up some white space. Let's also get rid of all this frickin' crap that I'll never use again. Because this was for my sanity while I was fixing things. It doesn't actually do anything because it's all commented out. So, whoops, that's not right. Use velocity if moving. Which racer cam state? Um, for for the final product, I wouldn't save the buffer here. But for testing purposes, there's no reason against it, and just moving it later. So it's going to be private, because in this class I'm leaving everything to be inheritable. So if there's a private variable, it'll also get my attention. And we could even leave a comment here to remove, or not remove, to move to SCO after testing. To move to SCO after testing. Private buff It's a type of float, probably. Private buffer float. That's going to be equal to 0.2 because we're thinking normalized, so we want it to be moving over like 0.5 of a meter per second, essentially. Since it's 1 decimal place long, it needs an F. It's just weird like that to declare it as a float, not double, for some reason. So what's the idea then? So then if our velocity, so if our A forward direction okay, so not quite right. Because forward direction is already a normalized representation of the acceleration. Therefore, its magnitude at most can be 1. Although I suppose that's still not a problem, because our magnitude would be 1, which would be more than 0.2. So technically that's still fine. Dot magnitude, not declaration, is greater than or equal to buff. Then we're going to do our execution, which would be this line. And it would be that line. So why do we do that? Yeah, because if then we probably want to wrap this in an else. Encapsulate good times, come on. Gotta encapsulate now. Which that should work. Okay, so we still use the normal cam anchor. If our velocity is not like that. So that should work. So if we control S, yeah, so that should all work, and it should all write out the same. Which means essentially nothing was changed. All works good. I have to check one quick thing. Okay. This is not working at all. Okay, there it is. That looks fine. Okay. So this is all set up. This should work fine. This should work exactly as it did before for the most part. We can flip over to this. We can hit play. And we can do a little fly around. Whoa. Whoa. So you can kind of see it slowly rotate a bit more. Actually fixes some of the other stuff I was having problems with too. That's pretty good. You'll notice it looks a little bit more to the side than it did before, which is something we could fix using tweening, not necessarily need to fix using the velocity part of this. Um, but it is there if we need it. So if we hit this, we see that our code still runs, hopefully. Maybe it wasn't on that side. Maybe it was just on this side. Whee! I did set it so it will realign if there's an issue. Did I delete that problem? Maybe. Um, my HUD wasn't getting updated, which was working the other day. It worries me. Alright, so if we play, I just want to look at my whole body. So there it looked down, like almost straight down. Um, so like I said, there might be something fixed there. HUD UI Racer is working. Oh, that worked. Weird. Did I take it off of the other cubes? I'm gonna say that's true. I'm gonna say only that one cube was active. That's why it failed. So I didn't do anything wrong except forget which cube that was on. Is better than screwing up the script. What do we have? We have 4 o'clock now. So this is about a full hour. I'm gonna try and cut the openers shorter to try and get see if that does better with YouTube and stuff. And also with this type of programming setup, you can always come in and ask questions partway through anyway, which will bring me back to my title card-ish scene. So as always, if you're watching after the fact, you can always watch live on twitch.tv at jib at BFP, which would be one of the best ways to get quickly asking questions and stuff through the chat and whatnot. Or you can always watch if you miss or if you have questions on past things that I've done. There's youtube.com at Bugfree Productions, which is really nice, which is just the exported videos of these, sometimes with title changes and some other little stuff changed. Um, but that's it for the most part, and thanks for tuning in. We're gonna keep going on, maybe just trying to polish this for a little bit longer, and then we'll stop here. Because it was really just the camera, and I'm surprised that I actually got it more or less working. Watch it become less as we keep going, but yeah, I'm gonna drink water for a minute here, and then I'm gonna continue. Okay, so with that, gonna go back to this screen, and nope, wrong screen. This screen and switch scene. There we go. So, being that this is all working, this should theoretically, I guess I should do one more test to be certain everything part of it works. And that's just this part, because I want to see that this is indeed adjusting with the velocity change, which it seems to be doing, so that's also good. Further proving that we can use just the velocity to track where our camera should be, which makes me very happy because I was dreading that part, to be honest. Absolutely dreading trying to figure out how it works with tricks and with other things. Um, so that is exciting. And then I can actually save the velocity if I want to continue adding force to objects as they jump or whatever have you. I can just save that velocity that it exits on and just keep applying in that direction, which is also fun. Um, it's very fun. So we have, which I probably won't do, but it would be cool. It could be cool if I choose to do it. We have um, that class to go back and look at. And is there anything else I want to do, right? So a forward dir and from. Do I technically want to use the cam anchor up? Um, so if I think about it, cam anchor position, RCC. Okay, so let's take a look at our Unity to refresh. Um, whole body, camera context. Cam anchor is the rotating body. Okay, so probably don't want to continue to use that dot up. Um, well, actually, if we use its up, that's not as bad. But let's do a play because I noticed the camera like switches weird, right? It like looks down at the bike before it hits the ground. Oh yeah, that is weird. So it's doing some weird stuff. Um, but as soon as it gets moving, it does perfectly fine. Um, what's our solve for that? So a cam position, a cam anchor position. I don't greatly want to use that cam anchor position much at all. Um, well, I do want to use this. I kind of need the anchor position because I need to know what I'm anchored around. Um, so that I might more so want to align my camera with something that isn't the cam up. So if we do cam up, cam anchor up, that's the body of it. So we move in the vector direction and then we move up. So, but if velocity, our velocity goes down, will this help illustrate? Yeah, maybe. So if our vector velocity goes down, right, then it's moving up already, and then it's moving the up again. So it's moving like straight vertical, which is gonna confuse the camera unless we do some extra constraints. Um, which would either be restraining it to a certain local rotation, which I don't know if that's quite the right course of action for that. Um, what I would rather do is let's try Cam state from distance. What if we just comment out this last part? Oh, that can't quite be right, actually. This part. What's our behavior? What's wrong with it? I commented out a semicolon. So what's, okay, we're holding on. So how is this with it? So hit play. It still had this kind of the same problem. The velocity is looking down, but it doesn't know what the camera's up should be. Um, so is there a way to do it without using constraints like that? What would it be? Let's look at the camera. Where's the camera at? Yeah, it basically rotates 180 around Y. So the problem with the constraint is I don't want a hard constraint because there's going to be a point where I need the camera to turn on the Y at some point to do a 360, because if I go in a circle, it does have to rotate and do that, right? Because it's not under the body, which if I put it under the body, it's going to be shaky and it's going to look terrible, which is the other problem. So we can't use constraints in that way. We can't use nesting due to that. So essentially, I need yet a different way to calculate the um, up direction, which would be the up direction of we can either do well, because this will happen the same thing if the rail goes down on the slope too, which will also be a problem. If I draw a line, from here, actually, hold on one moment. Let's get a paint up here. And then let's switch back to art2. Okay, that's just fine. Now, why paint? Because I just need to like sketch some stuff. So say our bike is a rectangle, right? Essentially what our problem is on two things. So this going down, so this would be my back point right now. If I don't use the up at all. So I need to figure out how to keep it in line with the bike, right? Because the bike is going like that. I also need to be able to do camera, correct? And what's the actual thing I need? So I need this up direction, this to be the up direction. So it looks down at the bike over the handlebars. Um, so it's a triangle, yes. Uh, this is less of a problem. And actually, this doesn't reflect what I need to do. I wouldn't want it back here because we're thinking this is the windshield, right? If that's the windshield, my dot actually has to be right here. Just still a triangle, but in a different spot. And if my purple is here, I don't want it to be up here. Right here is good enough. So that's kind of complicated. A little bit. So what we'd probably look for is not we'd probably still want to use the velocity, but we'd want to make it a little more relative to the bike. And I'm not sure what that exactly looks like. People with a better math background might have a better idea, or people who have done this a little bit more than I have would have a better idea. But to me, this doesn't look like a very good thing to solve, so it'll probably be a little bit of mucking around and seeing what it looks like. Alright, let's go ahead and just pull up the Unity then. So basically I need to know how to get this up here, which we could still use that as a guide. So we could still just look at, instead of using the forward in that case, use the, I don't really like that either, because that leads to the same problem we had. Leads to the same problem we had. Where I can't rotate the body without using the other thing. So what would it be? This might get cut. um, for the video part, but yeah, it's just hard to figure this one out. Up and down, forward, back. I want to say the fort would be in. Because when it's straight up and down with the vehicle is the only time that's really a problem, and possibly when it looks backward. If you get sent flying backward, the velocity becomes flying the other way. I can't lock the camera. I can't nest the camera. Um, quaternion rotate. Look at that. Well, we have the position, right? If we try and do a flip though, it'll cause a problem. Would solve all but that flip problem. So if we did it to the point where it looks, if we use another object to go to the point, look up at it, and then, rotate according to this thing's not up, probably wouldn't be bad. Problem comes to if this is to do a flip without changing camera. It does a flip without changing camera. What becomes of the direction? The direction would be off that way. So then you're from your point of velocity, which would be here, and then go here, and the up would be the opposite direction of the camera needing to face. That's no good. The balancer is a candidate. No, it's not. Well, it might be. The balancer is a candidate because it updates with the bike on certain states. It will not balance if it's not on the ground when we're doing our trick. But that's not a piece of code that you have either. So what do I want to do with that? Because the IK calculator for me calculates all the time, but it only rotates accordingly on certain things. Lean tween script affects tweening. Calculator, I'm going to view it. I was going to share this at some point anyway, so there's no point in hiding it. Use context. Calc tilts. It's on update. Use airborne IK. Okay, so if is grounded, then use ground IK. Ground IK, calc tilt left and right, front and back. That's if it's grounded. So this if statement can probably just get expanded to use the move context in a way that allows it to decide on its inverse kinematics. I disabled airborne IK. Why did I do that? Because I don't calculate those angles here anymore. But it'll still need to be changed for that one thing later. Let's go ahead and I'm gonna put a comment up here. Um, slash slash um make grounds IK use. So I'm not gonna go into an in-depth explanation of what this class was supposed to do. And now that I'm looking at it, I actually know that this won't work because this does update its position with the other guy all the time. To the ground, to the player body reference. So this is not a reference that that I can walk people through to use anyway. So we're gonna leave this one until the point where I actually discuss how I use the IK big air quotes in this case, because it's not quite IK. IK would actually have a little bit more, like inverse kinematics would have a little bit more math and measurement to it, actually. Make use ground IK use move state um, move state uh, calculation. Okay, because this guy's not gonna help us. Um, so actually we can close that dude. What does that mean then? So still run down some leads. IK calculator, it's not gonna help. It keeps in constant change with that angle measure. I could possibly change it to not align on certain states. That might cause problems when it does land and does want to measure though. Um, doesn't seem like it would be a big problem. Um, we could go check the distance between dot down, but then how does that measure a different angle? Anyway, this is probably math that I can't do on stream. I'm realizing it's probably something I'm gonna have to look at for a while and maybe talk to somebody else about. Because it is just weird to think about. And when it's weird to think about, I usually just let it drop and run for a few times. Because we only need the up to change. And probably just so it's not. Hmm. 'Cause now it'll work fine. Whoa. Okay, I removed that up and now the weird part of the collisions really affect now, huh? Well, this didn't work anyway. Anchor up, anchor from distance. So this just ended up making it go way back. Um, what if we do a cam anchor position, right? Anchor up. So I don't really want to use the up as the problem, right? Maybe the option is just to make a rotating piece that rotates with the gravity? With the gravity. Okay. Because if we have the little gravity helper, it's pointing along the side already, or just a helper, just call this basic rotation helper. We have this basic rotation helper pointing forward, right? Then he knows that it goes back, and we can set him to only update on certain states. Um, but that becomes problematic when we have a state that has a difference to it. Um, so this will help create a buffer that would go back a little bit, which is fine. But once this stops updating, I suppose if that stopped updating, that would be in the air, can't change direction, doing the rotation type stuff. Okay. Um, which would be fine. Camera would still be, camera would not change during that state. When that thing would unlock is when the other piece would also be unchanged. Because during stun, the velocity would still be forward, or at least in the same direction, and that would be up. So it would still push the buffer back this way, so that this becomes this, so that this becomes this. Um, so those two become equal, or not equal, they become the target, which would also work in stun, because in stun the primary problem is the other way. So if I just update something on every move state except the selected, it becomes bufferable. And we are how far in? We're a good 142 in. So, um, barring other things, this might be what I pick up with on one of the next ones, um, is testing this, because this is actually like easily half hour to an hour worth of code. And I like to keep these videos on 2-hour sections, just for my ease of recording and reading. So, this is the plan I'll be testing next, which I'll develop alongside you guys. You should be able to put this into your project, um, if you're following along with the bike race tutorial. That being said, there are a few updates I want to go through. So, uh, not not two. One, we have project go ahead. Um, so at some point, we'll probably revisit JSON. The VR is okayed and resources were okayed and shareability was all okayed. So there might be some future ones on that if I can combine it in with my streams and other stuff. So we'll have some of that. So project got greenlit, all good. Two, it's not much uh, else actually. It's just that thing. So we'll have more JSON and some more VR development type videos and stuff coming out soon. So stay tuned for those if that interests you. Um, just exciting news on that part. And where's my screens at? Here we go. So, if you enjoyed this and find any of this stuff helpful, remember you can watch live streams on twitch.tv at jib at BFP, or recordings over on youtube.bugfreeproductions if you can't make the streams or you just need to watch something to catch back up or need to refresh a different topic. Um, thanks for viewing, and as always, have a bug-free night.